What will we see in today's severe weather threat is a big question. And there's a lot of uncertainty around it. You may see a lot of uncertainty on social media, but we're going to cut through all that noise in today's video, and just give you the basics. Just give you what you need to know um, for today's severe weather threat. If you didn't already know, my name is Charlie, and welcome back to the YouTube channel. We're gonna dive right into this. So yeah, this is our outlook that was issued about 30 minutes ago to an hour ago Eastern time. And these are our risk areas here. You can see where they include. I'm not going to speak over what all they include, but yeah, you can see them here. Um, so if you're in that dark brown, that is a 5% chance that of a tornado within 25 miles of any given location, and a larger 2% marginal risk equivalent surrounding that. Our wind threat looks like this. It's the same size as the slight and marginal risks themselves, or roughly so. I don't know why it keeps doing that. Yeah. So yeah, we have this here. You can see if you're in this 15%, this yellow area here, there's a 15% chance of winds exceeding 55 knots or greater within 25 miles of any given location. And our hail threat has actually increased. We have a little bit of a higher chance off to the western areas here of the Texas-Louisiana border. So yeah, that is our risk area for today. Give you a chance early on here to read this. It will not cooperate. Either way, you can see it. You can read that if you want to read it. Right here is our mesoscale analysis. I'm going to zoom back out just briefly so we can look at everything here. Surface low as modeled is all the way up here in Canada. This was the surface low responsible for the storm system that we had yesterday. And our front is where I just drew that pink line. And so more importantly, what we're going to do here is click over to this. This is just our current radar. I'll go over this in a second. This area right here has some stronger storms embedded in it. None of them are warned as of right now, as far as I'm aware. And this stuff up here is rain. This could be rain and some snow, and the rest of it is unimportant to me. So that's our current radar. It's our current pattern. Our 500 millibar layer, we're going to do a little bit of analysis with this as opposed to just looking over it. So our trough here is still strongly positively tilted. However, we have a jet streak right here. And then we definitely have some, oh my goodness. We definitely have some sort of jet streak right here. And notice how our risk area is way down there. In fact, I believe I'll be able to turn this on. It's not going to come up under there. So yeah, those are our main features, and neither of them are close to where we need them to be for severe weather. So something to consider. I don't know. This broad southwesterly flow is mainly going to be responsible for what we're going to be seeing today. No real features of note in the 500 millibar layer. So that's our broad look, and then we're going to look in a little closer at the same product. Again, no features worth noting. 40 to 60 knots, even 70 knots in some areas of flow across this region that you're viewing right here. This is the deep south. Our risk area is down under there. I'm going to do that and turn on the SPC outlook. So you can see this green color right here is where the slight risk is, and you can see the flow overriding this region. So that's where that is. Our low-level jet being analyzed right now, its axis is primarily over the eastern parts of this risk area and is right along where these storms currently are ongoing. So that's probably one of the only things keeping these storms going right now, as thermodynamics are not much to speak of, really. So speaking of that, let's look at them. So this is Mixed Layer Cape. This has just come out. This is actually, when is this? Yeah, this is really new. This is like less than an hour old information, which is excellent. Look at our 500 contour here, getting almost all the way to the far northern areas of this slight risk. That's impressive for this time of the morning. And our 1,000 joule per kilogram line is well inland as well. So our instability is looking good. There's no capping out here. However, I don't know if it's going to let us pull it up on this website, but let's click on video. Yeah, it does. It will. Perfect. So this is our visible satellite. Maybe a little hard for you guys to see, but our main risk area is down here. Actually, I won't do that to you. I'll just overlay it. Interesting. It won't let me. So yeah, our risk area is in here primarily, and we have some clearing in this region. Some tops of these storms starting to poke through, but that's definitely contributing to all of this instability that we're building this early in the morning. It's impressive. So yeah, that's gonna conclude. That is our surface-based cape. It's a little bit different of a look entirely, actually. We have more convective inhibition to deal with, but higher values inland. 1,500 joules per kilogram have been observed inland of surface-based cape. Just to put that out there. Right here is our surface analysis. We can see flow here out of the south across most of these regions, or not moving at all. Some of these stations are reading 70 over 70, 72 over 72, 70s over the upper 60s. These are temperature dew point things I'm saying right now if you don't know. And all across this region, we have at least mid to upper 60s dew points, which is impressive. This time of year is more than enough to get the job done. So our front is back here and our low is all the way up there. It actually seems to have a dual low here, but the main low is near the US-Canada border. So you can hear that. If you hear that rumbling noise, that my garage is opening or closing right now. That's what that is. I apologize for that. Next up on the list of things to view here, this is the 9Z wrap, and what we're going to be looking at of the wrap is how our 500 millibar pattern progresses throughout the day. So this is like right now. If you think about where our risk area is, I'm going to draw it. I have to draw it in black, really. I can't. Think about it as there. That's not exactly the shape of it, but that's where I believe our highest risk will be. I'm just going to put it like that. And I'm going to click through the frames. We have this broad, at least 60 knots, generally 55 to 60 knots of flow across this region the entire day. So more than enough to get the job done. However, no features, no shortwave rolling through really. Maybe some very subtle shortwaves, but nothing really pivoting through here. Work our way down a little bit in the atmosphere. This is, as of right now, this is our modeled version of the low-level jet. Looks pretty similar, but this is maybe modeled to be a little bit stronger than it actually is. So for what it's worth, there's that. And right in here, our low-level jet axis begins to move to the south so that we have these stronger values of about 30 knots at the peak, based off of this. Some stronger areas, however, like these values in here could be convectively enhanced. I don't know. These could be like essentially driven off, because this is well within the cloud layer. Stronger winds within the storms themselves could be causing this. I doubt it. So this area could definitely be dealing with somewhat of an overnight threat. This is getting into tomorrow morning. So we'll go over tomorrow's stuff in another video. But that's our low-level jet. And then we're going to go down to the surface. This is looking at temperatures. As of right now, here's what's being modeled. Seems to be picking up on it pretty good. 70 to 72 degrees across southern Louisiana, and the mid to upper 60s across the rest of our risk area here, with southerly flow out of the Gulf. So yeah, just gonna click through some more of these here. Warms up a little bit, but it really depends on where you are, because areas like right in here based off of this won't get out of the 60s possibly because it's raining. There's just storm activity and cloud cover, so it won't get that warm. But this is something interesting, a little feature we have here. So you see our winds and our winds doing like that. So we might, this is just, I didn't even see this last time I looked at it. There's a chance based off of this that somewhere in here we get a little weak surface low to develop, with maybe some sort of outflow boundary attached to it. I don't know. I'm just kind of guessing at this point. It looks like it. And if that happens and we have a low right here, that will increase our vorticity. That increases rotation horizontally. So think about, if you can see my hand like this, rotation is like this in a storm. But rotation in horizontal plane is what we call vorticity. And that's just good for storm structure. Now this is overnight, but still, it's good for storm structure. It's good for tornadoes. So there's that. If that happens, this is our dew points. So I'm going to back this up to where we were. Again, initializing pretty well, although underdoing dew points, which is crazy. Most of these models overdo dew points, so maybe it's just a little bit behind. It gets them there, and just all through the day, southern Louisiana, Mississippi, and the southwest corner of Alabama stay in the upper 60s and 70s with dew points. Throughout the day, we could get higher dew points. Now, this is a product I like to look at. This is the same level. This is essentially surface, but notice how it says 0 to 30 millibar above ground level dew point. What this does is assumes that there will be some vertical mixing of air. So let's pull a sounding out here. Notice how we still have 70s. That's impressive. Flashbang warning for those of you who are sensitive. Sorry, it was a little bit late, but I just remembered. Okay. Yes, here we go. So throughout, we have turbulence. This is our surface. I got to pick a better color than that. So our surface is down here. The end of our moist layer up there. This is our inflow layer for storms. So the air that they are actually sucking in at near the surface is right here. So because if there are storms around, you will have turbulence in this layer. So essentially, I'm just going to draw a little bit of a circle arrow. I know that's not great, but still gets the job done, I guess. So that's going to take these drier dew points that we have up here and pull them down to the surface. Overall, it dries out the lower levels, but we still don't have it happening all that much. For those of you who don't have any idea what I just said, I'm going to circle some things here before I talk about this. This is a skew T. This is what you're looking at. Skewed temperature, logarithmic pressure. That's what it means. So on the bottom of your scale, the x-axis here is temperature in Celsius. You see 0 here, 50, and then -50. And then on the left, we have pressure in millibars or hectopascals, whatever you're used to reading. They go all the way up to 100 millibars, and we have our kilometer readings here. So this is getting up there, many miles above the surface, near the top of this. So what I just circled, what it's plotting is the temperature and dew point profiles with height. They send a weather balloon up and it has a little instrument on it that measures all of this information you're seeing. And it sends it back to whoever released it, so that they can see a cross section of the atmosphere. It's a very cool technology. But these two areas I just circled are moist areas. This area I'm going to circle in a different color is a dry layer. So if you think about turbulence, you know, when, spinning around here, it could bring some of these drier dew points in this region here and pull them back down to the surface, which overall lowers our dew points at the surface, which is not good for storms. So that's a little explanation, not the best thing I've ever done, but still, that's what I'm talking about when I say that. Notice here, I want this. It's going to be very hard for you to see. There are streamlines here. Notice how some of them kind of curl up a little bit, maybe. So this is kind of it's kind of indicating at a possible surface low development, which is an interesting feature. This is our mixed dew points. So it's assuming some drier air will be brought down to the surface, and we're still above 70, which is more than impressive. So I don't think we have anything to worry about with moisture in this. And then we're gonna move over here and look at our CAPE values. So I don't know what just happened. Yeah, we're gonna look at this. This is right about now. These blue values you see in the southern areas here indicate over 1,000 joules per kilogram. It's just a measure of instability in the atmosphere, or the ability for an air parcel to rise because it's warmer relative to its surrounding environmental temperature. So in the wintertime like this, we do not need these. You see the scale down here, and you see where we are midway. We don't need these 5,000, 6,000 joules per kilogram like you see in the summertime to get the job done, because we have so much flow aloft and so much wind energy that we don't need all of this thermodynamic energy to get the job done. But we're still getting over 1,000 joules per kilogram of mixed layer CAPE throughout our time frame here. So that's excellent. And that's all we're going to look at for that. That's our CAPE. Well, for what it's worth, I'm going to click on this. This is our supercell composite parameter. Starting now and just working our way on, possibly a little enhanced area here. 5, 6, possibly 7 to 8, depending on exactly what plays out today. So yeah, that is our model guidance that we're going to go over for a broader scale. Then we're going to get into our short range model guidance. This is the RRFSA model. Do we have a new one? I want to see how far along this is. Okay, so we have new information. I did not know we had this. So I'm going to click through these. We're going to see what we look at. So this is, I haven't even seen this, so I'm trying to absorb the information just like you guys. This circle, I just circle here and not the best color, is over some of the regions that will have the best overlapping ingredients. I believe there could be essentially a very localized, not outbreak, but just an enhanced area of reports of all hazards in this circle, just because our moisture is better, our kinematics are good, instability is better, temperatures are warmer. So because of that, I believe that we'll see that. And we click through the frames. I'm just going to hold the slider down. So we get what we were looking here, and click through. We begin to, getting towards the evening into the overnight hours, we begin to congeal all of this into a line, which I think we're going to get that for sure. And this line right here, whether that line ends up setting up down here or right where it is or up here, it doesn't really even matter. Anywhere in that circle I just drew, we have the potential to see some sporadic wind damage, possibly some reports of over 65 knots, what would be considered significant reports from the Storm Prediction Center. It's possible. And we seem that we have a refiring of, this is a refiring of storms, both isolated and a banding feature in both of these circles I just drew, and they are both in a lot of the same areas, which is interesting. But at the same time, with as warm as it is and as much flow as there is aloft, it wouldn't surprise me if we replace this air mass pretty quickly. Generally, the rule of thumb is if storms go over an area, that area is done for the day for more strong storms. However, been plenty of cases before where that wasn't the case, and storms roll over an area, and then a few hours later they get another set of storms that does more damage. I mean, that happens. That's believable. So that just keep an eye on it down in these southern areas. You just got a rough 24 to 36 hours to deal with here. Then also going to pull this up. We don't have, this is the newest, well, it's not the newest. So we can probably use this one as our actual newest model here. Click through the frames here. Okay, right here. This is 23Z, so this is going to be, it's all I can never remember. 5 p.m. I believe, Central Time. It's a little later than the RFSA, but the story's the same. 5 p.m. Central Time. These isolated, more intense looking storms that we have down here could be producing all hazards, but they have more of a chance because they're isolated to produce tornadoes than any of the other stuff that you see on your screen right now. And I'm just going to leave that circle drawn. And anywhere in that circle, see how they're starting to get another round. I don't have, this only goes out 18 hours on this run, so I don't have all of it. But I'm going to now erase this, and I'm going to draw a different. Right in here, I believe the circle is going to work. So we have storms rolling through right now that are somewhat intense, and then we have banding features that this could be producing wind damage, this could be producing hail, there's going to be embedded tornadoes in this, a little bit of everything. That's really weird looking that it does all that. So I'm going to pull this back to the beginning. That's the last of the short range model guidance we have to go over. And I'm going to click on this. What I'm about to show you is the entire run's worth of updraft helicity, which is helicity is vertical rotation. That's what we know is like a storm spinning around, you know, in the vertical sense, not the horizontal sense. That's helicity. So we're going to pull this out, and what this is showing is all of the accumulated modeled rotation of these storms. These values are not that high. I know, and if you know this site, you know that they can be higher. But this corridor here, the fact that there are values showing up, and there have been consistently for the last model runs, tells me that, and this is not even all of the event either. This is all of tomorrow, or all of today, and then some of tomorrow, but there's going to be ongoing stuff down here tomorrow that we're going to have to watch as well. So these values, while not high, they're there and they're consistently there. So definitely something to keep an eye out for is the rotation in these storms. They're not just going to be wind, and they're not just going to be hail. There's a very valid tornado concern with these storms. So as far as I'm aware, yeah, that's all. So that's all I have when it comes to new information for you. This is our most recently issued outlook here on the fly, just because I can. It might take a second to load. I'm gonna look at I'm gonna pull up the WeatherWise app. I'm not affiliated with them, but I do pay the pro subscription, and their site they've done a good job with it. So we're gonna take a slightly closer look here at our satellite just before we hop off here. Is it Mesoscale 1? Or maybe it's Mesoscale 2. Well, that's a shame. Okay. So we're going to click on this here. This is similar to what we were looking at. This is a little bit closer. A loop should be able to load through here, unless my internet's acting weird again. But generally, this area right here is clearing out. Not great for severe weather. This area back here is starting to clear out too. This area is starting to clear out. Areas of the Gulf Coast are starting to clear out as well. Everything's starting to clear up, which is just not what you want to see for severe weather. So yeah, you're going to get to see this nice animation here of the sun coming up over these regions. But notice, um, we have this consistent area of clear, or generally clearer skies in, I can't think, Louisiana and Mississippi. And you can really see those here. You can see the ground through the clouds, and that means the sun can too. And it's heating the surface, it's warming everything up, and just priming the atmosphere for more intense convection. This is our infrared imagery right now. You can obviously see our stronger cluster of storms south of Meridian, and north of Hattiesburg, east of Jackson, Mississippi. So I'm gonna leave this open. That's not important to you guys, but yeah, that's all I have for you. But yeah, if you're in this yellow risk area right here, pay attention today. Be safe, and I might get a video out later. So if that's the case, tune in, and I will see you guys in the next one.